Another thing I can tell is that after a gun has been fired, I can start looking at the patterns to look at possible firing distance, how far away was the gun shot from, and things about the gunshot residue. So let's kind of go into that and kind of discuss things. So if I actually have a suspect weapon, so I have a crime scene, I see the bullet holes impressed at the crime scene, and I might be able to say something about the pattern of how far away it was shot from if I have a suspect weapon. So what if I have possible, like this might have been the weapon, I can take it and test fire it at different distances. I test fire it at 1 foot, 2 feet, or maybe in meters, a yard, 12 feet, 15 feet, 20 feet. So I test it at different distances, and I'm going to save the target pattern from each of those differences to look at what was the typical distribution of it. So it's going to leave behind when I fire it. Remember there was that big explosion where I had all that gunpowder? Well, there's sort of all these sort of particles that get sent out with that. Along with the bullet, I also have this residue that's sent out. It's unburnt pieces of part of gunpowder. The smoke from it comes out. So all of these things come out with it. If I am close enough to the gun when that happens, as this spray of stuff comes out with the bullet, I may have some of that residue left behind on wherever it hits. So if the target that all of this is impressed on, but it has to be kind of close. If I'm 50 feet away and I have some smoke coming out of the gun, it's not going to appear on the target 50 feet later. So this usually has to be fairly close to observe these sort of residue patterns. And that precise distance from the handgun can be judged if I now look at a match. This is what I test fired the gun at, and here is the actual wall or victim, and I look at the pattern there, and I can do some matching and say the gun was fired from 4 feet away, from 8 feet away, and I can get some things. But I'd have to have a test pattern to really match it up. I can get some general ideas if I don't have the test pattern. So I might find enough similarity in that shape and density of this residue pattern to base an opinion about the distance. If I don't have it, I can get some ballpark ideas just from knowledge of how guns work. If it's a contact shot, meaning the gun is up against the wall, whatever it hits, it doesn't have to hit a person, but generally, so let's think about it hitting a victim. So if it's right, if you have the bullet, the gun barrel pressed against somebody's side and you shoot the gun, all of that residue pretty much gets right there, right? There's nowhere else for it to go. So you tend to get a star-shaped tear pattern around the bullet hole entrance. Again, it might be going into a piece of clothing or into a body, right against the skin, depending. And the bullet hole is often surrounded by a rim of this smokeless deposit of all this, like all the stuff that's coming out of that barrel from that explosion, gunpowder explosion, kind of is all there. And you tend to get a rim and a star-shaped tear hole. If it's pretty close, like a foot away, you'll tend to get a halo of that vaporous lead smoke. So a lot of that stuff coming out is going to be there, but it's going to be less of a tight rim and more of a general halo. If I'm then close, but maybe not quite that close, so probably, on the 2 to 3 foot distance, and again, these are very vague, I might get these, now I'm starting to get these spattered specks. It's a little less, it gets spread out a little more, so those individual specks tend to be there, and I tend to see sort of this speckled pattern over a bigger area. And I'm not going to see like a specific spot. If it's farther away than that, and again, it still can't be very far, because if it's very far away, I'm not going to see any residue. But past about 3 feet, I'm not going to deposit any powder residues, but I might have a dark ring around the hole known as what we call a bullet right. Like when that bullet goes in, some of the stuff left on the side of the bullet might give me, might kind of get impressed upon there. So these are the sort of patterns. It's easier to see when you look in the, but here's that star-shaped pattern, and I get a tiny rim right at the center of where the bullet hit. This is now that a little further away, half, this one's saying 6 centimeters is maybe 3 inches, and I start to get that halo effect. At these farther distance, I get more of these speckles, and the radius of the speckling is going to be comparable to the distance. So the farther it is out, notice I get this speckling pattern, but it's over a bigger area. When I start getting far away, I just see a single pin, like all this extra vapor and soot and unburned particles doesn't really make it to the target. Shotguns are different. I still can get some idea of the distance determination, but it's much less precise. But this is now related to, remember, there is no barreling, any rifling on the barrel, but there is a choke. There has to be something to kind of get the shot to sort of aim at a specific area. And that choke and the diameter of the bore, there's a very precise pattern of that. That's going to be related to the pattern of shot. But generally speaking, that depending on the choke and depending on the distance, I'm going to get the farther away I am, or the less choke that I have, I'm going to have a bigger pattern of shot. Like where the shot lands is going to be spread over a bigger area. So if I'm farther away, it will be over a bigger area. If I have less choke, I have a bigger area. So if I have a very tight area, that suggests it was close shot and that there was a good bit of choke on the gun. So that's not very precise, but I can get some ballpark ideas of what might have happened. And if I know specifically which gun it is, which shotgun it is, and I know about the choke characteristics and I can do some test firings, then I can have a better sense of that distance. Let's look at some of these specific pictures because that general picture I showed really wasn't great. So here is some of these looking at like contact right up against the victim and very close, like a couple inches away. So this star pattern that we see, and we see this sort of what we call this rim of pattern right there, like because all of that stuff, all that soot is coming out from the gun and it's all going right here into this circle area. And then I kind of see this star pattern. This is slightly further away. Notice now I kind of see this is more like this halo. See this little halo here? And I get a little bit of spatter. But this halo here will not be present on the next ones. Now I get a little bit further away. Far enough away that I'm close enough that I still have this pattern of these unburnt particles of gunpowder that get left behind. And as I get bigger and bigger, it gets, spread out over farther areas. You can't tell so much, but you can kind of see this is concentrated a little bit here. I don't really have an area of concentration. It's kind of all around. This is another example of a contact shot. Again, that star-shaped pattern. This is going into a piece of denim before it went into the body, so you can kind of see what it looks like. So now I also have that, if I could do a chemical analysis on that residue, that might tell me something about the ammunition itself. So if I have garments, if I have, might be a piece of wall that could be, or if it went into a lampshade, I could take that lampshade in. I might be able to look at the gunshot residue, what's in it, the actual chemical composition of it. So we have a couple of things. And of course, one of the ones we do is this gunshot residue on the shooter themselves, because some of this stuff gets fired backwards as it's ejected out. Most of it's going forwards, but some of it comes out the back area or the sides of the gun, and that's going to maybe land on the hand. So I can examine them. One of the things that we can do is that we can do something called the Grice test. It's a chemical analysis test that can look for gunshot residues that I can't see. Again, remember we have that smoke that comes out and it has a lot of nitrates in it and some other things. There's some trace metals in there, and I might be able to see them with some of these chemical tests. I can use infrared light. It turns out some of these chemicals will show up in infrared light, especially if I have a dark piece, someone's wearing dark clothing, and I can't really see if there's any gunshot residue, but if I put an infrared light on it, I now can see, right? You really can't see this here. I think it might have been here is where it is. I think that's what this chalk border is saying, this is where this is. And then this is that, looking at it a little bit closer up. So I can see this sort of, it's hard to match up whether this here is this here, if they're exactly side by side. But look, this is the end of the zipper, and I don't see it here, so I think this is a farther back view. I think this is here, this is here. But we definitely can see there's something there. There's definitely a hole there, and I can see that rim as it went in, that wipe. I also, again, like I said, this primer discharge, the primer is going to be kind of more, the primer is coming backwards, and that primer has some unique stuff in it to make it fireable, and that can be deposited on the firing hand of the shooter. So this is what when we're testing for gunshot residue, this is what we're looking, is if that person recently shot the gun and I swab it with some surface and then I do a chemical analysis on that swab, I can see if there's gunshot residue on there. I'm really looking for the things that I'm going to find in the residue, which is going to be lead, barium, antimony. These are specific chemicals that I'm looking that are in primers, and they're not in a lot of other stuff. So it's kind of unique. It can also sometimes tell me about the size and the shape of the particles containing these elements to say whether a person has fired or handled a weapon or a discharged firearm. So what we would do is we would swab it. These are like a little sticky patch. So this is sometimes at Halloween they have these little stamps where there's a little stamp with an ink pad, like impressed upon an ink pad, and it's got like a cover on it. So it's almost like that. So this is sort of a mildly sticky substance. When you pull off that clear top, you have this little swab that you can swab around. And we would want to take 2 on the left hand and 2 on the right hand. So we kind of have a standard or reference. What does the regular hand look like? What does the firing hand look like? You'd want to know whether the person was left or right-handed identically to compare these samples. They would all go into so you'd collect it. They're covered so that they're not going to get cross-contamination, and they're going to be sent in for what we call SEM. We'll talk about that in a second. So this is what that looks like, that stickiness checking someone's hand. And so then we will use this scanning electron microscopy, or what they talk about is X-ray spectroscopy, or EDS. So these are specific tests that chemists can use, like qualified analysts can use, to look for specific chemicals in that gunshot residue. Again, we're looking for these specific type of particles. So SEM is looking for the size and the shape of them, but it turns out that certain chemicals have certain size and shape. And then this, the X-ray spectroscopy, this EDS, will tell me about what kind of particles I have. It will tell me if I have lead, antimony, and barium. So that's testing the chemical composition. The SEM is testing the shape of the particles left behind. And both of these are sort of, there's a standard of testing methods that we put in. We'll talk a little bit more about these, that we have these ASTM guidelines of saying, if you're going to test for this, this is exactly the procedure you have to use. We all use exactly the same procedure so we get some standardization, and you can compare from one analyst to another analyst and know that it's all being done the same way. Unfortunately, we have something called secondary transfer. If I shoot a gun, I do get some gunshot residue on my hand, but then it can transfer from that to all sorts of other things. Everything I touch somebody else. Also, some of that, this is shot coming out. The closer you are to the gun, the more gunshot residue you have on you. But if there was somebody standing nearby the shooter, they might just test positive from being in the vicinity of the gunfire. Also, if I washed my hands, right, then I won't test positive for gunshot residue, even though I did shoot the gun. Furthermore, there are some things just in nature that are very similar to gunshot residue, and so sometimes it's just not a very specific test. So this test has kind of gone out of favor more recently because it's just not definitive. The idea would be you take this test and it says, yes, this person shot the gun. And what you get is, yeah, this could have been the shooter. But if they don't have it, it doesn't mean they weren't the shooter. And if they do have it, it could be secondary transfer and not the shooter. But it might at least say, hey, you were in the vicinity of a fired gun and you were probably at the crime scene. So it still might help to identify that this person was a bystander. But it's good for the beginnings of detective work. It's not good for court.